Hey guys, this video is going to be a little bit different from my usual videos because I am using it for class purposes as well. So it means I'm going to go over the sponge and the learning target, which I don't always or usually do in my videos, my YouTube videos. I also might go a little bit slower. Whoever is filling in for my class this afternoon, if the students raise their hand and need you to pause or rewind something, if I go too fast or whatever, please feel free to do so. Okay, so on our sponge, we're practicing two concepts here. We're practicing and reviewing how to graph a line if I give you the equation, and then we're practicing if I give you the equation, you give me the line, the equation of the line. If I give you the graph, you give me the equation. And let's blow this up a little bit bigger. Okay, so the first one where we're graphing it. My slope is the 2, so 2, and we'll make it a fraction, 2 over 1. And then because it's positive, we're going up 2, 1 to the right. And we're starting, our y-intercept is the -1. 0, -1. So our first point that we're going to graph is that y-intercept, 0, -1. And then we're going to follow the directions that we wrote for ourselves, which is to go up 2 boxes and 1 box to the right. Up 2 boxes and 1 to the right. Up 2 boxes and 1 to the right. Up 2 boxes, 1 to the right. Okay, then we're going to follow that pattern backwards, down 2 boxes and 1 to the left to get some points on the other side. Okay, once we have all of our dots, we need to connect them. Don't forget to put an arrow on each end and write the equation on the line. Y equals 2x minus 1. Now might be a time that you would pause for kids to catch up. Okay. The second problem, I've given the graph, and now you have to find the slope and the y-intercept so that you can write a y equals mx plus b for them. So remember, you connect any 2 dots along the grid lines. Okay, you got to use the grid lines to make the triangle. I had somebody make a triangle that looks like this. Okay, that is not using the grid lines. That does not help us figure out the slope. Okay, so we have 3 boxes down and 2 boxes across. Remember that slope is your rise over your run. So 3 is my rise, that's how many boxes up and down, and 2 is my run. And it's negative because my line is going downhill. My B is that y-intercept point right here at 2. So I will sub in y equals -3/2 x plus 2. All right, our learning target for today is to be able to find and use an equation in situations with direct variation. Direct variation is a very specific linear equation where that looks like this. Okay, it could be written in any of these 3 forms. Actually, these are all the same form. What's different is that sometimes they use M. Sometimes you'll see A. Particularly A I included because it's on the graphing calculator next year. They will represent the slope with the letter A on the calculator. And in specific situations, sometimes they represent it with K. But they all are the same exact thing. They all represent the slope. Why do they use different letters? I don't know. Okay, but they all are the same. And I just wanted to show you that they use different letters, more thinking in a forward direction. So when you see this in another course somewhere, or in a textbook, or if I know you all go home and Google this stuff, I'm sure. And if you see it with a different letter besides M, you know, it's all the same thing. The y-intercept, notice there is not a plus or minus b. That's because in these types of situations, the y-intercept is the origin, and it's 0. Okay, that's what makes this direct variation. Direct variation has a y-intercept of 0. If you do nothing, you get nothing. Okay, so here's examples where direct variation occurs. Things like hourly wages. Let's go back to that 0-0 conversation. If you don't work, you don't get paid. 0 hours, 0 money. Okay, so in this case, this equation I wrote, P equals WH, I just took the letters that would have to do with working and subbed them in for the letters Y equals MX. For example, instead of Y would represent our paycheck. Your paycheck equals your wage, which is how many dollars you earn per hour, times how many hours you work. Okay, so your paycheck is your wage times your hours. So that's an example of direct variation. And in this case, the money you make per hour would represent your slope. Distance formula. That's a formula I'm sure you've used in science class or maybe math class before. Distance equals rate times time. So rate would be like your speed, how fast you're going. All right, how far you go means, well, how fast did you go times how many hours, minutes, or seconds were you doing that. Okay, so those are all things that use direct variation. Okay, I'm going to skip this screen and I'm going to go right to this screen. And then instead of notes examples, we usually do notes examples. I know you all want to have Halloween fun tonight, so I'm going to use, instead of notes examples, I'm going to use homework examples for teaching purposes, so we can get some of this homework done before you leave class today. All right, so the following table, this is not on the homework yet, last screen, and then we'll switch to homework. The following table represents the hours worked and paycheck for Bob. You're probably thinking, you know what, Bob probably knows how much money per hour he gets. Why are we having to figure that out? Well, that's true, except that, you know, in the real world, when your boss tells you you're going to make a certain amount of money per hour, that doesn't mean you get paid that in your check, because they take out stuff like taxes and Social Security and FICA, whatever that is. Okay, so maybe Bob is writing down his paychecks and keeping track of them because he wants to know how much does he make after taxes. All right, so when it is saying to find the M or the A or the K, whatever, remember how we said all those 3 letters essentially mean the same thing. We're trying to find Bob's wage in this scenario. Okay, so if he worked 9 hours, he got $81. If he worked 7 hours, he got $63. Okay, so how much is he getting paid for 1 hour? Well, I bet a lot of you are saying, well, 9 times 9 makes 81, and 7 times 9 makes 63, and you would be correct. Okay? Now, if that didn't come to you immediately, the 9, then try this. Pick any column you want, any column you want. Let's say I picked this one. If you work backwards and divide the second number divided by, the bottom number divided by the top number, 135 divided by 15. You type it in that order, 135 divided by 15. You would get 9. In fact, I could pick any set of 2 numbers in the table and I would get 9. Okay, that is my rate. That's my wage in this case. It's my slope. We're using all different words to represent the same thing. So I'm going to write an equation, y equals, but instead of m, I'm going to put the 9, x. So his paycheck is $9 for every hour. Use your equation to find out how much Bob will get paid for working 20 hours. Okay, so we just said that he gets paid $9 an hour, so we do 9 times 20 equals 180. Now, guys, listen. This is very, very important. Look at the screen right now. A lot of you could have done 9 times 20 in your head, and I understand that. But you can't just write 180. You can't leave this part out. And just write 180, okay? Most of your points on your Regents exam next year, and I know that's a year away, but we got to build habits now. Most of your points comes from you showing how you got the answer. Very few of the points are actually awarded for the answer itself. Most of the points are awarded for how you did it. So if you're leaving out 9 times 20, you're going to take a deduction in points. And it's going to be a big deduction in points. That's where most of your points come from, is how you got it, not what you got. So make sure you're writing that. Okay, let's look at number 1 on the homework. It said Linda made $18 for 6 hours of babysitting. Find her hourly rate and graph her total earnings per hour for the 6 hours. Let's do the graph first. When you're decoding the question, okay, $18 for 6 hours. 6 hours and $18. Time is always X. That's a good thing to write down somewhere. Time is always X. Okay, that means that on the X-axis where I'm going to graph the hours, I need to count at least up to 6, which I can easily make counting by ones. No problem. I can make it to 6. Just 6, actually. All right. But up the side, that's my Y value. Anything that's not time is my Y value. Okay. Linda made $18. Money earned. Make that look more like a D. There we go. Now, I at least have to make it to $18. So I can't count by ones. 1, 2, 3, 4, 5, 6, 7, 8. I'm only going to make it to 8. Even counting by 2s, I'd only make it to 16. Okay, so you could count by 3s. You could count by 5s. All right, I'm going to choose 3s. 3, 6, 9, 12, 15, 18, 21, 24. Okay, so for 6 hours, she made $18 and put a dot there. Now we need a second dot because this is a line. Okay, we need a second dot. Well, the easiest one is if she works no hours, she gets no money, and that doesn't come out very well, so I'm going to switch to red here. Okay, so we've got these 2 dots. No money, no hours, no money, or 6 hours, $18. And we're just going to connect these dots. Okay. So there's your graph. Again, if you need to pause this at any time, just hit pause. Okay, so hourly rate. How much did she get paid per hour. Well, that paid per hour kind of tells you what you're going to do. So money per hour. I apologize for that. You probably just heard a notification come through, super loud. $18 per means divide, hours 6. So her hourly rate is $3 per hour. Write an equation for the graph. So that's my slope, that's my rate. Y equals 3x, just subbing that in. How much would she earn after 8 hours? Well, $3 an hour times 8 hours, 3 times x, 3 times 8, we're just subbing 8 in for x. She would get $24. Let's go down and look at 3 for a minute. It says Dave drove 292 miles. 292 miles in 4.5 hours. Ooh, tricky, tricky. They spelled out 4.5. We're going to use 4.5. Okay? So, hours is a unit of time. That's going to be on my x-axis. And 292.5 miles, that's going to be a value on my y-axis. So again, I can easily make 4.5 counting by ones across the bottom, and I'm going to label that hours. Up the side, up the side, 292.5 miles. So the side is going to represent miles. But we got to make it to almost 300 up the side. So counting by ones or twos or something like that's not going to work. Counting by tens is not going to work. Okay? Now, what do you count by? Guys, you're not trying to make it fit 292.5 perfectly at the top. That's not what you're trying to do. Okay? What you're trying to do is, a rule of thumb, count by an amount of money, currency that we would have. For example, we have $20 bills. We have $50 bills. We have quarters that are 25 cents. We have a dime that's 10 cents. If it's not money, don't count by it. Do not count by 17s. There's a reason we don't have a $17 bill. Okay? We want things that are easy to count by. So I want to make it to at least 300, and so what ends up working best is counting by 50s. So the point we're going to graph like 0, 0, that's a given. If he doesn't go anywhere, if he hasn't driven any time yet, no time has gone by, he doesn't go anywhere. So 0, 0 is one of our points. And 4.5 is right here, halfway in between 4 and 5. So I'll follow that up until I hit almost 300, because it's 292.5, so almost right about there. Then I'll connect these 2 points. Draw my arrow. Pause it if you need to. Let's do the bottom part. Average speed. Okay, well, speed is miles per hour. That decodes this for us. Per means divide. 292.5 divided by 4.5. We're trying to figure out how much he went in 1 hour. That's your speed. Turns out that's 65. Write the equation for the graph. Y equals 65 times the amount of hours, 65x. So how many miles would he drive after 6 hours? Well, 65 miles in 1 hour times 6. Type it into your calculators, guys. 65 times 6. That's not one I'm doing in my head. 390.